a specialist in Internet of Things. Our primary focus is building hardware type devices and making sure hardware type devices work, but software and cell phone app development and things of that nature is also something that we dabble in. Obviously also very interlinked to Internet of Things in the sense that you have both halves, the hardware and the software side. And then another point, I typically like interactivity. So if there is a question that somebody has, I typically prefer it if somebody would ask me that question there and then. Even if it does break the train of thought slightly, I tend to find that if I've missed out on something, or if the interest lies somewhere else, I'd prefer to catch that early. So with a bit of housekeeping out the way, I like asking the rhetorical questions. Why are you here? And perhaps you can add more on while I'm going through this. But I think the main cause to learn more about Internet of Things, understand the technologies used, and sometimes how those technologies came about. Maybe you're interested in implementing some of these technologies into your own business, networking these types of devices into your own business. Maybe you have a business and you're planning on implementing these types of technologies into your customer base, ultimately improving your business, gaining value from technology, and if there are other reasons, you're very welcome to pass them on. From a business perspective, why are we in business? And sometimes it becomes hard, and there's philosophical reasons, but it ultimately, in my mind at least, boils down to that one word on that first line, making a profit. We're ultimately interested in making a profit. If we weren't making a profit, we probably wouldn't be in business, and we certainly wouldn't last in business if we weren't making a profit. So the profit motive, I think, is a very strong motive, at least for the vast majority of businesses. And in order to make a profit, you typically need to have good customer service. You need to know what's happening. You need to be able to supply quality products. You need to be able to get ahead of competitors with better types of products, better quality types of products. And I think that this is where technologies like Internet of Things really thrives, because you can develop new products, you can improve the whole value chain, if you will, of your entire business using technologies like Internet of Things. There have been, and I'll go through a little bit more case studies, businesses that have invested small amounts of money into Internet of Things and ended up saving millions purely because they had a better grasp of what was happening in their business, thus making a bigger profit. I will also say this: technology for the sake of technology isn't necessarily good. So that old saying, if it ain't broke, don't fix it, also comes to mind. But as I say again, Internet of Things, very, very big opportunity to change dramatic aspects of a business for the good fairly easily. So what do you know about Internet of Things? What is it? What does it do? And this is the sort of start. Internet of Things is an information generating tool. Essentially, you place devices on ordinary objects and you start getting information. And in line with the fourth industrial revolution, we're starting to interconnect this. And at this point, I also want to make the point, Internet of Things isn't necessarily a new technology. The connectivity around what we're doing with an Internet of Things device is where it becomes quite new. So Something that I presume not a lot of you have done very recently is flown in an aeroplane. Now, the cockpit of an aeroplane, at least the Boeings and the Airbuses, for example, have a whole host of sensors that will tell you what your altitude is, what your speed is, what the temperature of your left, right, center engine is, what your air pressure might be, all of those different items, and that relays that to the pilot. Now, that's 60s technology. A thermometer, for example, is not particularly new. But what is new is the ability to connect those types of sensor readings to an internet connection and gather and store that data. So we can start to say things like, we see that this particular engine, when it's operating at this particular height, gives us this reading. If we see a change, we can automatically notify a support crew on the ground to say that this engine might need some pre-maintenance, because we have a computer looking at all of that data all of the time. And this is why I use those last two lines. Offer businesses tremendous insight into the heart of their operations. When you can start to see what data is happening throughout your business, throughout the day, without deploying people to do that, you get an IoT meets undercover boss scenario where pieces of hardware are telling you what's happening. And I've got lots of great anecdotes about that, but I'm not going to go into all of that at this precise moment in time. I'll do that in just a few moments. So what is IoT? Specifically, there are a couple of components. Mainly, it's an electronic device, typically in the form of a sensor of some sort that's connected to the internet. And those electronic devices get attached to an ordinary object and, as we tend to say, measure, monitor, and track. So I gave an example of sort of a larger scale, but a smaller scale example of an IoT device is a panic button. A panic button that you press a button and it alerts a security company. Interestingly enough, no different to what your cell phone would do, which is another broad type of Internet of Things device. Here's a short list or a longish list, depending on the way you look at it, of different typical types of measurement, monitor, track applications, air quality, GPS, pH, water, etc. All when combined together can become quite useful in various applications, from mining from a safety perspective and an object collision avoidance systems to simply a loss prevention system to farming systems, so that farmers know how much water has been or how much rain has gone into each segment of crop without driving out to read a rain gauge, to hospital environments, to business environments, to even a simpler delivery type business that has, say, medical goods. IoT in practice, I promised a few moments ago to go through a few more. There are a number of use cases, and I quite liked a few of these. About a year ago, a big beer manufacturing company implemented Internet of Things sensors around their beer bottling system. And they were ultimately looking at trying to avoid spillage and trying to ensure that they had better fill ratios so that they weren't overfilling or underfilling as a result of the foam. And they used sensors connected to the internet through their piping system. They had cameras around where the beer was being filled to improve the quality of their beer. And it was quite a successful system. Another really nice instance, a big courier company, also one we've all likely used in the last sort of 12 months. They implemented very simple GPS tracking systems on their stock or their bulk trolleys, of which they have tens of thousands. And they implemented this, interestingly enough, in just one country. And they found that their trolleys were actually even leaving the country. And they were big enough to realize savings of up to about 250 million euros a year, which is quite phenomenal considering that each device was only costing a couple of hundred euros in their case. There was a logging truck optimization. Actually, this was in South Africa, and again, a very simple type of GPS system was installed on the trucks, not very dissimilar to the tracker type systems, but in this specific instance, they were looking at optimization of the trucking routes. Due to it being in a mining forestry type environment, the roads are very dynamic. They're changing all the time. And if you have one particular truck, a little bit like a railway system, going down one road and another truck going down the same road, they get jammed. And it becomes very difficult for them to reverse out because they obviously can't turn around. So the optimization was implemented and saved tens of thousands into the millions of rands. Then you get some sort of practical systems, the irritation type systems that I've quite liked, gas bottle maintenance. This is implemented from a restaurant perspective as well as a home perspective. And this is literally done by putting a digital smart scale underneath a gas bottle. Since we know what it starts at, we know what an empty bottle weighs, we can tell you when a gas bottle is finished or not. But pragmatically, about 15 years ago, there was a gas supplier in South Africa, in the United States, and they realized that they had a maintenance contract with their customers, and they were changing, in some cases, a full bottle with a full bottle, and it was costing lots of money. So they actually started building their own network. And come 15 years later, they now make more money out of their connectivity network than they do out of their gas supply, which I suppose gives you an idea of how powerful the network can be when you do have it in place. A little bit of a luxury example of some customer service improvements. A company based in France, a high-end watch company. I forget the name, but it's of the sort of level of Rolex. They implemented a very simple ticking system inside their watches, and when the ticking becomes unusual in terms of what the watch should normally expect, it sends a notice through for maintenance, and the watch gets checked in all automatically. So the customer doesn't need to do anything to service their watch. And then finally was an instance that we did ourselves a few years ago with a temperature probe. We have a very accurate temperature probe we have, which was being used for a food production company. They had a specific lease requirement to keep their fridges to a minimum of 15 degrees. A maximum of 15 degrees. And they had set their fridges to about 13 degrees on the little thermometer sitting on the side. But when they used our technology, they realized that the fridge was actually sitting at about 11 degrees, 4 degrees colder than it should have been or could have been. So they warmed it up, and they ended up saving a couple of 100,000 rand a month purely in electricity, purely because they have a reading of the temperature of their fridges every so often. And what's more is if their fridges go out of range for even a moment, our system will send them an alert so they can take corrective action immediately, which both saves them money and gives them better customer service, which interestingly enough they've had to use before when there's been a customer come back and the customer has then seen that they had very, very detailed records of the temperatures of their fridges, which pleased the customer quite a lot. So moving on from there, it's not written down here, and if I'm completely honest, I felt slightly embarrassed writing it down here, but Internet of Things isn't about tracking you because of coronavirus, and the Internet of Things technologies like 5G, which I'll talk about a little bit later on, also doesn't give you coronavirus. So while it's probably not something that was top of your mind, believe it or not, in my industry, I've heard this quite a lot, and it's out there, even though it's not true. But at the same time, Internet of Things isn't about that smart fridge that orders the milk for you when you run out. While no doubt in the future you're going to be able to do that, it's not about that. It's about many, many other things, like some of the examples I just gave through. Internet of Things isn't new. I used that example with the cockpit already of the aeroplane. I think it just is one of those types of technologies that has a slightly longer adoption curve because it's a little bit more complex and a little bit more difficult to implement. But it's not a new technology, and the sensors that we're using aren't new sensors either. They're largely the same. The only thing that's really new within the Internet of Things space is the type of internet connectivity, which is now being designed specifically for these bulk numbers of devices. And then finally, your cell phone is a broad type of Internet of Things device. So is your TV, so is your car, so are many other items around your house. So it is happening already. I think something that's important to note is you tend not to think of Internet of Things as an Internet of Things device when it starts to have a functional purpose. So the cockpit of an aeroplane, when it's connected to the ground control, isn't an Internet of Things device. It's simply an aeroplane with a cockpit in it. So why is IoT so important? And I think this first sentence, first line really says it all, and is the be all and end all of what IoT is really all about. Data. Data is an electronic currency, more so, I suppose, than a Bitcoin or the likes. Knowing something and being able to use that something within the context of your business or around what you're doing is an incredibly valuable aspect of your business. Knowing that a customer can walk into a shop, and if they make a purchase within 3 minutes, you can make other assumptions, or depending on how they walk around, or depending on the things they browse on your website, can all help you make decisions. And I think the second point, ordinary objects get a voice. So you're able to know what's happening around the world without being there to witness it. You can tell if somebody's sitting on a chair. And if somebody's sitting on a chair, you can play a particular video. I've even seen smart signage that has a little smoke detector. And when somebody who's smoking walks past that sign, they'll sell cigarettes. When there's somebody that, or when there's a detection of rain, it will sell umbrellas and the likes. So the ordinary object gets a voice, and the data of how that gets used becomes very valuable. I've gone through devices to some extent. I think the main point I want to make over here is an Internet of Things device, while it sounds like a very complex, very technical device, is actually a very uninteractive, a very dull device to some extent, in the sense that it's something that just gets put on an object and doesn't do much. And as I made the light-hearted comment, what my mom heard is an Internet of Things device is a little box attached to something. The little box sometimes has an LED and sometimes flashes. And in the grand scheme of things, my mom is right. And I think that what's quite nice about that is because of the nature of the technology, I can start putting a very simple watch onto, now, for example, my grandmother, who can't use a cell phone, but she can have a little watch on her wrist, something she's familiar with, something that's easy, something that from her perspective doesn't mean very much. But that same watch can have a GPS in it, which means if she walks away or gets lost somewhere, I'll be able to find her. I can put a little accelerometer on her, or at least on the watch, and I can tell if she's moving or not, or maybe to be a bit more proactive, I can tell if there's been a high impact, which might indicate that she's fallen. So the ordinary object in that case would be my grandmother, and there's no interactivity that needs to be done on her side. She doesn't need to know how to use the watch. She just needs to wander around or live her life like she normally would, not dissimilar to any other type of object in the world that you might want to get some information on, not too dissimilar to the fridge. The fridge doesn't mind if the temperature is above or below 15 degrees. It's just switched on or it's switched off. The device starts to give information about what's happening, and we can then make decisions, interactive decisions on a live basis as to what's happening. I'm going to skip a few slides because I want to start getting into some of the technologies. And here we go. Sorry. So Internet of Things technologies essentially forms part of two main technologies. The one is the hardware, and I think a lot of people have heard of or have been or let me put it this way, have come across the technologies from a hardware perspective. The new items are the connectivity and the way wireless technologies work with these devices, which is ultimately quite important. So when we think of Internet of Things, not too dissimilar to a cell phone, you need a way to connect to the internet, and you also need a way to power the device, which is sometimes easier said than done, because as we know, our cell phones tend to run flat after a couple of days if we're very careful. If we're still using a Nokia, maybe 2 weeks, but for the rest of us, maybe a day or so. So we need very lightweight technologies. We need very lightweight internet connections. So when we talk about that, you essentially have this table, and it's much easier for me to point. So I don't know if I have a pointer on here. I don't think I do, but it doesn't matter. So you have there at the top there power consumption, on the left-hand side range, and on the right-hand side bandwidth, which with the center being the dream. So if we think of your cell phone has the capacity to move a lot of bandwidth, but by moving a lot of bandwidth, you therefore use a lot of power. So you then have to sacrifice a little bit of range. If you want range and bandwidth, you then have to use a lot of power. And therefore your battery goes flat, or your current usage becomes quite high, and so forth. So Internet of Things devices, typically because they're powered devices that get put somewhere, need to have very big ranges, but also need to have very, very, very high battery longevity. So our bandwidth tends to suffer quite a lot, in the sense that we can only sometimes send a couple of bytes. Like, for example, my name is the max message capacity for some of the Internet of Things applications. So it's not a lot of things. But that said, if you want to know a time or a temperature reading or a GPS coordinate, you can do so with a great deal of ease. So talking about some of the technologies, there's essentially three categories of technologies: wired and your, I suppose, wireless type technologies go in there, as well as mature technologies, long-range wireless and short-range wireless. And I'll go through that in just a second. So your wired mature technologies would simply be your Ethernet and your straightforward Wi-Fi, the types of technologies that I'm currently using to broadcast this Zoom session. Now, in terms of technologies, there's not very much that's going to change, or there's not very much that's new that's going to dramatically impact the IoT ecosystem in this space. Ethernet fiber, I'm going to skip out on that to save some time. GSM, I just want to very quickly mention GSM is the your cell phone data, where 5G is obviously the next generation of GSM technology. So this is where it starts to get a little bit more interesting. Long-range wireless, specifically in the low power, low bandwidth space, are starting to emerge, of which there are four leading technologies. In South Africa, you'll see on the bottom right-hand corner, there's a technology called Sigfox, Sigfox. And they're a radio network that covers probably about 90–95% of the surface area of South Africa at the moment, or the population, let me rephrase that, it's about 80% of the surface area, with a low range, low power network. So essentially how that works is very similar to how a radio works. A device would broadcast a signal over the radio, and a receiver somewhere located, sometimes as much as 100 kilometers away, would pick up that message and translate that into a server and turn it into something that's useful. Some of the pros with Sigfox is it's very cheap. You've got great distances, and there's a big area that it covers. Some of the downsides are that you can't communicate back to your device very easily, because essentially it's designed to switch the device off. So from a pragmatic perspective, when a device sends a message over Sigfox, it switches on, sends its message, and switches off. It doesn't check if the message has been sent or not. Technologies like LoRa, which is the logo just above that, is very similar. The main difference is it's not a commercial network where you're paying a device fee. You build the network yourself. So it's a little bit like your own private network. So similar types of technologies as Sigfox. The major benefit over Sigfox there is that you have zero device connectivity costs, but obviously your connectivity costs at the onset are a lot higher. So as an example, if you have one cow, for example, to track over your entire farm, Sigfox would be a really good choice. If you had 200,000 cattle to track over your entire farm, you might want to set up a LoRa base station or multiple of them, so you can keep track of all of those cattle and see what they're doing and where they're moving, and any other pieces of information that you might want to know about that. I know my partner had my business partner that is, had a great deal of success in the United States with a car dealership using a LoRa system. They essentially used a LoRa system to keep track of the stock that they had. But what they also tended to find is when they moved a vehicle from one dealership to the other, it disappeared somewhere in the middle because they obviously lost range. Then you get two other technologies, NB-IoT and LTE-M, both of which are cell phone technologies, both of which are potentially viable in South Africa, and they would be distributed through the likes of the MTN, Vodacom, Cell C type companies. Possibly not Cell C at the moment, that is. I know MTN and Vodacom are making great strides using those types of technologies, but they're not yet ready. So in the long range space, technologies like Sigfox are very mature, and technologies like LoRa, if you're prepared to invest in building the network yourself, are readily available for you. Some detail about Sigfox, specifically because they're your best choice in the IoT space in South Africa at the moment. They're founded in 2010 in France. I think what's most important for a company like Sigfox is they have a footprint around a lot of countries in the world, including they're about to launch a satellite into space, which will give them connectivity around the globe. Now, what's particularly nice about Sigfox is, as one company, you can essentially roam from country to country to country. So you could have quite effectively a tracking device on your suitcase when you travel from South Africa to Europe. While you're flying over Kenya, you'll get a message. While you get into Europe, you'll get a message. You go to the United States, you'll get a message. You go to Australia, you'll get a message. You go to China and Singapore, etc. You'll get messages, which is a really great benefit of a technology like that. I'm going to move on from that. LoRa, as I mentioned earlier, it's largely a build-at-your-own network. They do have some infrastructure in South Africa through various companies, and that then would operate similar to how a Sigfox operates, but then that's obviously only local. We'll move on from that. NB-IoT, I think this is quite an important aspect over here, specifically the third line, the center line. Both MTN and Vodacom are planning on using NB-IoT. Now, NB-IoT is a very similar type of technology to Sigfox as opposed to GSM. The major benefit of a technology like that is you have a much bigger payload and you have two-way connectivity, which for mission critical messages is sometimes quite important. Switch a device on, send a message, wait for the message to be received, and have a ping back to confirm that it's been received, and then switch off. That's obviously a big deal when it comes to mission critical, then you know that the message has got through. Some comparisons very briefly. Sigfox hardware price is really quite good. NB-IoT, on the other hand, is quite bad. Power consumption for Sigfox networks is typically quite good, whereas NB-IoT is a little bit worse. That's primarily because of technologies like the two-way communication and how it communicates. Network fees exist on Sigfox, is cheaper than NB-IoT, but obviously can't compare with free from a build-your-own network. But obviously there's a price point difference. Sigfox has excellent coverage in South Africa. Virtually the entire of South Africa is covered, including more of the Kruger Park than Vodacom and MTN. LoRaWAN obviously doesn't have very, very good coverage, and NB-IoT will eventually get good coverage, but they don't yet have. Sigfox has very small message sizes, a few bits, not a lot. It's what gives it good power consumption, but then there is a downside over there, whereas NB-IoT has a much larger message size. Downlink is not particularly good with Sigfox, whereas I said earlier, NB-IoT is very good. Congestion because of the radio network on a public frequency is less good with technologies like Sigfox and LoRa. That said, in South Africa, you tend not to have that much in terms of competing bands on the same frequency, just simply because South Africa doesn't have as much clutter as some of the European or American frequencies. And then most importantly, because Sigfox has been going for quite a long time, there's quite a substantial ecosystem. You can buy off-the-shelf hardware, you can buy off-the-shelf dashboards, you can buy, or you can find companies that can work with all of those types of technologies and implement it for you relatively quickly, whereas the other technologies are a little bit harder to do. In the short range space, there's a number of technologies. For this specific purpose, I think I'm only really going to cover that middle logo, which you should recognize as Bluetooth. Now, one could argue that Bluetooth should have been placed into the mature category of technology, and if you made that argument, I'd largely agree with you. The main difference, though, is Bluetooth has fundamentally changed the way they are approaching communication and their messaging system, where previously it was sort of in your Wi-Fi type range. It's migrated a lot more towards a full IoT implementation, of which there's two main things that have changed. One is you can mesh Bluetooth, meaning you can have one base station and you can have devices that will hop from one device or messages that will hop from one device to another, which allows you to have a smaller complex network with a wider range. And then second to that, Bluetooth's range has increased from Bluetooth 4 to Bluetooth 5 from about 100 meters to about 1 kilometer. And 1 kilometer is quite a substantial amount of distance when it comes to communicating with a device. Bluetooth obviously is also quite well supported, and there's a lot of stuff out there that can help you get going with Bluetooth type technologies. I'd also just quickly like to mention that Bluetooth is the type of technology that the coronavirus app is using to check contacts. So essentially what's happening is the app is scanning for Bluetooth frequencies in and around where you're standing. And depending on how long it sees the particular Bluetooth address, which is unique to everybody, it can then decide whether you were at risk or not with that particular person or not, which is a really effective way of doing things. Interestingly enough, it's also the exact same technologies that retailers use to track the number of people in and around their store. Obviously, it's quite a convenience for them to have everybody walking around with a Bluetooth-enabled phone in their pocket. Moving on, Bluetooth has some pros and cons. I'm not going to go through that. I think what I really want to do over here is have you look at that little image in the center of the screen from a Bluetooth meshing perspective, where you can have the main connected device, and you can have meshing devices, and you can have devices hopping from one through to the other, which gives you a great deal of connectivity relatively easily. So where you have a factory, for example, instead of using a GPS technology to track your stock, you can start using a Bluetooth technology to track your stock, which is a lot cheaper, a lot more battery efficient, and will definitely work indoors, whereas GPS tends to struggle. I'm going to move on from those technologies. Those technologies that I've just covered through are really far more useful in the home automation space, which I'm going to skip out for now. Common question that I'm asked, which will win? So at the moment, Sigfox is doing really well in the long range space. Technologies like NB-IoT and LoRa will always have a space. So broadly speaking, I don't think that there needs to be a winner in the long range space. In the short range space with the home automation type, that's not too important for me right now. New technologies, something that is of great importance. I mentioned tracking type technologies. Bluetooth has come up with something called angle of arrival. And it's essentially an indoor positioning system. And they tend to get accuracy sometimes as accurate as a couple of centimeters, depending on the number of base stations they have. But essentially, by looking at the angle of which the signal is sent from the beacon to the particular device, you can start getting an idea of where in space, in a three-dimensional space that device is. And obviously, if you have three devices, that can give you both a physical coordinate in both 2D and 3D. So you obviously have a vertical orientation as well. The great benefit of that is you can actually tell if something's on the first shelf, second shelf, third shelf, fourth shelf, etc., which is very useful for a whole host of technologies. Obviously, warehousing is a good one, but mines have actually used this type of technology very effectively for collision avoidance, where they have Bluetooth devices on each of their pieces of heavy equipment, and you'll get a signal if the piece of equipment gets too close to other pieces of equipment, because you obviously know where in space it is. Sigfox new items, they have their own internal tracking system, somewhat similar to how GPS works, but obviously using a base station with timing in milliseconds. And they're looking at trying to get that to accurate within a couple of 100 meters, which will give you a better idea of where an object is without firing up a relatively battery expensive GPS. They have a project that they've codenamed Admiral Ivory, where they're aiming to get a device under $1 that can do basic GPS type tracking about the size of an envelope. In fact, I lie, about the size of a credit card. So that's a project that they're getting closer and closer to. And obviously that makes the types of technologies that we're talking about a lot more functional for the purposes of implementing in the real world. And then they're also looking at sending low orbit satellites up into space, which obviously circumnavigates the globe multiple times per day, resulting in a maximum of about 2 messages per day, but from anywhere on the planet, which means you can then start having some very, very low powered devices that can be put on things like yachts or other types of devices that are very remote, that don't need very many messages or very much communication on a daily basis. I'm going to move on from that. Something that is of great importance is the security around Internet of Things. No doubt you will have heard of some of the stories of people getting hacked and so forth. So these are things that you should always be aware of. What's quite interesting, though, in terms of the latest network types, the Sigfox devices and the LoRa devices and Bluetooth devices, for that matter, don't directly connect to the internet most of the time. What's happening is they're connecting to a base station that's connected to the internet. So your risks are lowered quite a lot by using those types of technologies. But definitely don't let security be the bottom of your list, because you can get yourself into quite a lot of trouble. At the same time, people might not be interested in stealing or hacking into your device itself. They might be interested in gathering some of the data you're gathering, which puts things like your Protection of Personal Information Act into jeopardy, because obviously you need to keep that safe, and you need to make sure you're keeping it for a valid reason. I'm going to move on from that, and that's going to basically take it to the last little section of my presentation. What do you want out of and Internet of Things implementation. What do you want to achieve? And some of the main points over here is understand your end goal. What is it you want to achieve? How do you want to, what purpose do you have for the particular data you need? And then obviously start compiling a mechanism to start gathering it. So if objects could talk, what would they say? If you wanted to know what was happening with a particular chair, what type of information would you be asking of that chair? What type of information would you ask of a gas bottle? Do you need to know how much is being used? Would you like to know how much is being used at a specific point in time? Maybe for safety purposes, would you like to know that the gas is currently actively running or not? Maybe you don't have a flame on your stove, but the gas is currently leaking out, in which case you have a safety concern. Those are the types of questions to go through. Where to start, 5 W's, where, what, why, and we took a little bit of a liberty with the how. Communication mechanism, what type of communication do you need? Long range, short range, what type of power are you going to need? Because obviously there's a trade-off over there. Human interface, is this going to be a button that's going to be pressed? Is this going to be something else? And then obviously a very important aspect of designing your own setup is the analysis. What's the most, let me actually rephrase that, how are you going to use the data that you're getting? And what types of systems are you going to put in place so that you can use that data? So now we know, for example, what the temperature of our fridge is. If the temperature of the fridge gets above 15 degrees Celsius, what do we do? Do we sound an alarm? Do we send a message to a technician? Do we go downstairs and adjust the thermostat? All those different types of decisions become quite important in the thinking process when we're looking at an Internet of Things activity. And I'm not going to go through all of these because I'm now getting to the end of my time. Sorry. And that's then taking me to the end of the presentation. Obviously, I've left a little bit of time for some questions. If anybody has any questions, then I'm obviously very happy to answer them. And also, obviously, don't forget to unmute your microphone. A little hack that's quite useful is if you hold the space bar down, you don't need to toggle on and off. It automatically does it for you.
Gavin, thank you so much. I think coming into this, the participants on the call are all at different levels of understanding IoT, and the way that you have explained it and presented it to us this morning has put so much into perspective, specifically for me. I know that Ariella is on the call and she's so much more advanced than us. And Ellis as well, but just to understand, I think the relevance is understanding what your business needs are and what actually is the IoT, and in terms of the security that you've discussed with us, the examples that you've given us, the products, etc., etc. I'm so grateful for this, and I think it's a subject that many people don't understand. Although the way that you have facilitated this morning has been absolutely exceptional. And from me personally, I'm so grateful to have people like you to educate us and give us knowledge and insight on such an interesting topic. I don't see any questions in the chat box. So while people are thinking about if there are any questions, there's Ellis, he's bound to have one.
No question, just Love the technical. Thank you very much, Gavin. It was really good, very informative. So variables. It's quite a confusing market with all those variables. Thank you.
Yes, you're quite right. Thank you.
So before we end off our webinar this morning, I'm going to ask Laurie just to put up a quick poll. If you wouldn't mind completing the 2-question survey for us, and that will then be followed by a donation poll. As you know, Orchard is a non-profit organization. We rely on donations to assist us to help business growth, and anything that you are able to contribute would be greatly appreciated. We are not in a live environment and do not charge for any of our webinars. So if you are able to give something towards our cause, please do so. And Gavin, I am so grateful, as I'm sure Laurie and the rest of the participants on the call are. I will be sending all the participants a recording of your session this morning with my brief overview and key insights into what I have found relevant. And we greatly appreciate your time. As I said, we're extremely fortunate to have such experts as you that support ORJET.
Thank you so much.
Thank you so much, Gavin, for sharing your wealth of knowledge with us this morning.
Thank you.
And we wish everyone a good rest of the day. We look forward to seeing you all at the